everyone, this is Mrs. Krause, and this video is called How to Analyze a Pedigree. The guiding question that we're going to address during this video is how can we analyze a pedigree to determine the possible patterns of inheritance? Okay. So, let's go ahead and get started. Okay. The steps that you should always use when you're trying to determine the possible patterns of inheritance shown in a pedigree are first to assign your alleles for a particular pattern of inheritance. For example, if you are trying out autosomal dominance, you would use big A to represent the trait allele and little a to represent the normal allele. You're also going to write out the genotypes that would correspond to each individual on the pedigree for the chosen pattern of inheritance. And if all the genotypes work and you've gone through the entire pedigree, that's the correct pattern of inheritance. So let's go ahead and try that out. You have a chart at the end of your notes that gives you 4 possible patterns of inheritance: autosomal dominant, autosomal recessive, sex-linked dominant, and sex-linked recessive. It also assigns the alleles for all of those patterns of inheritance and lists the possible genotypes and associated phenotypes. Now we are going to use this chart as we tackle the first problem on your pedigree worksheet, which looks like this. So as we go through the video, you're going to be filling in your responses for pedigree number 1 on your pedigree worksheet. Okay. So this is the same pedigree that's shown on your pedigree worksheet for number 1. And let's say we wanted to try out the autosomal dominant pattern of inheritance. If it's an autosomal dominant pattern of inheritance, then big A is going to represent the trait and little a is going to be normal. The possible combinations of those alleles would be big A, which would give you the trait for your phenotype, big A, little a, which would also give you the trait of interest, and little a, which would be normal. Okay. So our next step is to fill in the genotypes of all individuals on the pedigree, assuming this is an autosomal dominant pattern of inheritance. So if that's the case, all individuals who are normal would have to have the genotype little a. So we're going to fill it in for 1, 2, 3, 4, 5 individuals, all but this one down here, the son. So for the son, he shows the trait because he's shaded in. So he has to have the genotype big A, little a, or big A. He could not have gotten a big A from either of his parents, so this pattern of inheritance is impossible. It doesn't work. So for autosomal dominant, on your worksheet, you are going to circle no for the autosomal dominant pattern of inheritance. If you circle no, you do not need to fill in the genotypes of the father and the mother, these individuals right here. Okay. So let's try out our second pattern of inheritance. If we're following an autosomal recessive pattern of inheritance, then big A is going to be normal and little a is going to represent the trait because it's recessive. On the right-hand side, you see the possible genotypes and associated phenotypes. And again, this comes from the chart at the end of your notes. So if I went through and I identified my individuals with the trait, and it looks like there's only one, then they would have to have the genotype little a. Is that possible for a child to have the trait when both parents do not? With autosomal recessive, it does work. These parents could be big A, little a, in which case they would appear normal, but they could both pass on a little a to their son. Now these 3 children, they all have to have a big A to be normal, but we're not sure if they're big A, or big A, little a. They could get a big A from one parent and a big A from the other, or they could get a big A from one parent and a little a from the other. We don't know. But in any case, we did not hit a sticking point. All of these genotypes could work. So we're going to say yes for autosomal recessive. This is a possible pattern of inheritance for this pedigree. We're also going to fill in the genotypes that we identified for the father and the mother. They both have to be big A, little a. So if I go to my worksheet, I'm going to circle yes for autosomal recessive, and I'm going to fill in big A, little a as the genotypes for both my father and my mother. moving on, we're going to try the sex-linked dominant pattern of inheritance. This would be a trait that's carried on the X chromosome and is dominant. So therefore, our alleles are going to be a little bit different. X big A is going to represent the trait because it's dominant, and X little a is going to be normal. And these are my possible genotypes and associated phenotypes. Anytime I have two X's, that's going to be a female, and when I have an X and a Y, that's going to be a male. Okay, so before I even put in my big A or little a superscripts, I'm going to go through and for all of my males, my boxes, I'm going to write XY. And for my females, my circles, I'm going to write XX. So for this pattern of inheritance, any normal female has to have the genotype X little a to be normal. So I'm going to fill that in for 1, 2, 3 females. Any male that is normal has to have the genotype X little a y, so that would be this male and this male. And this male right here, because he shows the trait, has to have the genotype X big A y. Now that's a problem. The son is going to get his Y chromosome from his dad. He can't get it from his mother. That means he needs to get his X chromosome from his mom. It looks like she only has X little a, so she could not have given the X big A to her son. So this is impossible. This pattern of inheritance does not work for this pedigree. So I'm going to go back and I'm going to circle no for X-linked dominant. Okay. My next one that I'm going to try is sex-linked recessive or X-linked recessive. So in this case, X big A is going to represent the normal allele and X little a is going to represent the trait. So I'm going to go through and it looks like I can really easily identify the genotypes of my males. The normal males have to be X big A y, and my male with the trait has to be X little a y. Now the mother's normal, so she has to have at least one X big A, but she could have an X little a, and in fact she would have to if she's going to pass that X little a on to her son. But it's possible. Now for these two daughters, they could either be X big A, if they got an X big A from each parent, or they could have received an X big A from their dad and an X little a from their mom. So we can't narrow down their genotype, but it looks like the entire thing works. So we're going to mark yes on our worksheet for X-linked recessive. And our father is going to be X big A y. And our mother is going to be X big A, X little a. Sorry, it's hard to tell the difference between my X big A's and my X little a's on this. The only other pattern of inheritance that we need to check for is Y-linked, which is when the gene is carried on the Y chromosome. There are a couple tricks that we can use to determine whether it's possible for a pedigree to be Y-linked or not. The first trick is if there are any females on the pedigree that show the trait, it is impossible for it to be Y-linked because females don't have a Y chromosome. In this case, that trick doesn't really help us because none of our females show the trait. So we're going to have to use our other trick. Our other trick is if a son shows the trait, his father had to show the trait because the son inherited the trait from his father. So there has to be alignment between the father and the sons. In this case, the father and this son do not show the trait, but this one does. And that's impossible if it's a Y-linked pattern of inheritance. So we're going to go to our worksheet and we're going to circle no for Y-linked trait. This would be your final response for pedigree number 1. And you are going to try out pedigrees 2, 3, and 4 on your worksheet. And you can check the key to see if your answers are correct. Okay. I hope that was helpful. We have addressed our guiding question, how can we analyze a pedigree to determine the possible patterns of inheritance? Thank you very much.